Welcome to the Human Experience Podcast, the only podcast designed to fuse your left and right brain hemispheres and feed it the most entertaining and mentally engaging topics on the planet. As we approach our ascent, please make sure your frontal, temporal and occipital lobes are in their full upright position. As you take your seat of consciousness, relax your senses and allow us to take you on a journey. We are the Intimate Strangers. Thank you for listening.
The Human Experience is in session. My name is Xavier Katana. We've got an incredible program planned for you guys today, so sit back, have a drink, and enjoy this conversation. Our guest for today is Mr. Randall Carlson. Randall is a master builder and architectural designer. He has over 40 years of experience as a researcher of ancient mysteries and as a geological explorer. By way of Sacred Geometry International and the Cosmographic Research Institute, Randall investigates and documents the catastrophe-laden history of the world and also how earlier cultures were likely more advanced than previously thought in an attempt to unlock the mysteries of the true origins of us as a species. Randall, wow, what a mouthful. Welcome. It's a pleasure to have you here, sir. Welcome to HXP.
Well, thanks for having me.
Yeah, I've been trying to get this conversation set up. I'm so glad that we were finally able to put it together. So why don't we kick this off with an introduction? Tell us, for the people that don't know, tell us who you are, what you do, and how you got to doing what you do, please.
Oh, well, Xavier, that's an interesting question. It's just something that I got interested in science, at a very early age. I grew up in rural Minnesota where the effects of the Great Ice Age were everywhere about us. And so early on, I just got interested in nature, the natural world. I read a lot, so I was always reading things about geology, geography, the weather, mass extinctions. I was very, very interested in dinosaurs, of course, as a lot of boys and kids in general were back in the 50s and 60s. So one thing kind of led to another, and it was just a lifelong interest that I've kept up for many decades now. And once I kind of launched my business in the 80s and got to where I could actually afford to do some traveling, I have been traveling typically 3 or 4 times a year to investigate various sites of interest to me. These could be geological sites, they could be archaeological sites or paleontological sites. Mm-hmm. In a very abbreviated version of it, that's kind of how it all came to be. I majored in geology in college, mm-hmm. With a minor in astronomy. So I had those two things kind of in my academic background. Although I've not been a practicing professional geologist, it's been an avocation of mine now literally for about 35 years. So I don't take normal vacations, sightseeing vacations. I do, you might say, research trips. And I'll usually go with several like-minded people who are interested in the same kind of things. And we'll go spend anywhere from 1 to 2 weeks, 2.5 weeks, exploring various sites that are interesting to me, that I feel that are important in trying to, shed light on this shifting paradigm that we're in the middle of right now. Yeah. The realization that there's a whole lot more to our history than had been previously recognized. So that's a big part of it. And now it's gotten to the point where I've accumulated enough mass of material and information that it seems like the next logical thing to do is to try to share this, because I know there's a lot of people out there that are interested in the same kinds of things. And perhaps in some of these areas, I've got a bit of a head start, so I can save people some time. Mm-hmm. So I'm doing these podcasts, and this is our first one. So it's great to be here.
First of many, hopefully. Well, I mean, I heard about you through Joe's show when you were on with Graham, and Graham has been on this show a bunch of times as well. And, there is something about these questions that sort of, for those of us that are seekers, we're looking for the answers to these questions. Who are we? Why are we here? Is there a God? These are big questions. What are the origins of our species, because it seems like the origin of how humans came to this current point is very concealed. It's very hidden from, the purview of mainstream history. So, I want to set the stage, as it were. Let's paint a picture for our audience, and maybe we can start with, what is the current geological standing that historians have for the human species as it were now?
Well, of course, geological science is in the midst of a major upheaval right now. But for most of the 20th century, the dominant paradigm was one of gradualism, a very strict gradualism. The term that has been used, it's a mouthful, it's uniformitarianism, which basically extrapolates into the past by looking at things that are going on today. And it was always considered to be pseudoscientific to begin to try to look at forces or effects that we can't see going on around us today. So the uniformitarian method is very powerful, because obviously by making observations of processes that are currently underway and then extrapolating into the past, we can learn a lot. Mm-hmm. However, when it becomes dogmatic, then it becomes very limited, because it's apparent now that, there are things that have transpired in Earth history that do not have a modern analog. And so what uniformitarian perspective gives us is the realization that, yes, there have been things that we can't explain in terms of modern processes. So, this all began to shift back in 1980, was a major turning point when 3 separate teams all proposed that a major asteroid or comet impact had been responsible for the Cretaceous-Tertiary mass extinction that killed off the dinosaurs. And this kind of began to open the door for scientists to reconsider catastrophism in Earth history. Because prior to that, anybody who invoked anything that was, unlike modern processes was considered to be a fringe, pseudoscience, all of that. So you had, what's called the Velikovsky effect back in the 1950s, when Immanuel Velikovsky wrote a series of books about Earth's cataclysmic past. Mm-hmm. And he wrote several books that were really have stood the test of time, the main one being Earth in Upheaval, where he, in the mid-1950s, there was a lot of anomalous information and data out there that did not fit into the uniformitarian paradigm. And this came from multiple venues, such as hard geological science, observations within nature, but it also came, and this was what he was open to, was the traditions of mythology and legends and folklore that seemed to have this catastrophic implications to them. Stories about the great floods, about fires from space, great upheavals in nature. So what he did in the mid-50s was he collected all of this stuff together that was pretty much available at that time. Well, so far so good. But then what he did was he attempted to explain it and interpret it. And this is where he got attacked, because he came up with a theory that, there are people who follow Velikovsky today who will kind of religiously hold to his theories of origin, but he came up with an astrophysics that basically got savaged by the scientific community because, he theorized that Mars and Venus were ejected from Jupiter and came very, very close to the Earth. And it was these close passages of Mars and Venus that triggered the catastrophes, the great floods. And he had discussed a pole shift in there. And then, of course, the astronomers went crazy over that idea. However, in fact, they then wrote a book called Scientists Confront Velikovsky, where basically the whole book was a refutation of Velikovsky's astrophysics. However, what they didn't touch was his catastrophism research. That came through unscathed. Nobody even attempted to refute some of the evidence for great catastrophes. Well, fast forward, about 20 years, and in the mid 70s, Charles Hapgood came out with a work called Path of the Pole, where he essentially kind of did a Velikovsky approach, and he collected together all of the evidence that had accrued in the interim that pointed to catastrophes in Earth history. And then his attempt to explain that was through pole shifts. And he theorized that perhaps there were triggers that could cause the crust of the Earth to slip over the mantle, and that this crustal slippage is what had triggered the catastrophes. And again, that got attacked. In the end, Hapgood sort of pulled back on that idea. Interestingly, he said, well, it definitely appears that great catastrophes have happened in Earth history. I'm not sure if a pole shift was the cause of it. And that was, like I said, I think that was 76 or 77 when he came out with Path of the Pole. And then, of course, a few years later, you get the extraterrestrial impact hypothesis of like I said, multiple scientific teams. Walter Alvarez was probably the most well-known. They were the ones who discovered the iridium layer at the KT, or Cretaceous Tertiary boundary, over in Gubbio, Italy. And once they discovered that iridium, they knew that iridium was essentially a cosmic material, that it's a siderophile, which means that it likes iron and it binds to iron. So the assumption was, in the early days of the Earth, all the iridium that would have been at the surface of the Earth bound to iron, and then as the iron subsided towards the core of the Earth, it took all the iridium with it, which left the crust of the Earth deficient in iridium. However, it's known from the study of meteorites that they're very rich in iridium. So when they found this iridium layer right there at the what they call it, the magic boundary layer, which is only a few inches thick, and they knew that below that the dinosaurs had existed, but above that there were no more dinosaurs. It was like the end of the Mesozoic era, which was the great era of middle life. So they found this iridium layer, and they said, well, could this possibly be the result of some kind of a cosmic impact? So they began to contact colleagues around the world, who subsequently began to look at other Cretaceous Tertiary boundary outcrops, and at every one they looked at, they found this iridium layer. So from the amount of iridium that they could now estimate had been deposited worldwide, knowing the percentage of iridium that would be in an asteroid, for example, they were able to calculate that it would require an asteroid about 6 miles in diameter to distribute this much iridium around the globe. And then from that, they were able to determine that, well, if a 6-mile asteroid hit the Earth, what size of a crater would it create? So they then extrapolated and estimated that a crater of maybe somewhere 100 to 150 miles in diameter. This is all in the early 80s.
Okay.
Then we get to the early 90s, and lo and behold, they discover the Chicxulub crater buried under the northern Yucatan Peninsula of Mexico, and it dates to exactly the Cretaceous Tertiary boundary. So there we go. So that pretty much shut up all the doubters and the skeptics who were trying to say, oh, no, it was a much longer process, a slow, much more protracted, an impact would be all of a sudden.
Right.
But you also had paleontologists taking a much closer look at the layers going right up to the boundary. And what they discovered was that, it does appear that the dinosaurs were prolific right up to the boundary, and then boom, they were gone. So, wow. And I followed all that. I followed all that, and it intensified my interest in catastrophes. What I got more interested in, though, was the ice ages, and because I grew up in a landscape that had pretty much been sculpted by the great glaciers, because right where we lived was near the margin of this, what's called the Laurentide ice sheet, this massive 5 million square mile ice sheet that covered 3/4 of Canada, down till 13,000 years ago. So right there where we lived was on the fluctuating margin of that ice sheet. So what it did was it created all kinds of unique, interesting landscapes. And, I used to get this impression, even as a small boy, that there was something there. There was something hiding in the landscape, some kind of story. And so only later when I grew up, did I begin to understand that, yes, indeed, there's a very profound story that's being preserved in these landscapes. And so that's kind of how it went. I mean, as I think about it, I'm sure there'd be many other points along the way that I would say, yes, that was a seminal point where I really got interested in this sort of thing.
It's fascinating. I mean, the research you're doing, it's uncovering so much. I mean, there's so much information to pack in what you just said, but I'm sure you heard about this on Wednesday, last week, I think it was, there was an asteroid that narrowly, quote, missed Earth overnight, and these astronomers had no idea that it was right next to our Earth. So it seems that maybe these catastrophes are more common than we would generally think that they are.
That's one of the things I've been arguing now for years, Xavier. Interestingly, maybe by coincidence, several weeks before I did an interview on Russia Today. Actually, it was around Asteroid Day, which is June 30th. And on there, I basically said, we can expect these things are now coming by us about once a month. So, and I made the point that a lot of times they're coming by us and we don't know that they're right on us until, boom, we see them flying by out there.
That's a scary concept.
Yes. And this one was estimated to be possibly as big as, 400 feet in diameter. Now, you've probably heard of the Tunguska event of 1908 in Siberia.
Have not.
Okay, Tunguska, 1908, Siberia, very, very important event for people to know about.
Okay.
This was probably a piece of the comet Encke, which is a member of the Taurid meteor stream. Came in, flew into the atmosphere early on the morning of June 30th, 1908, just north of Lake Baikal in Siberia. And it was a lower density object. So, like I said, it was about 150 feet in diameter. And what happens when a lower density object comes into the Earth's atmosphere, the atmosphere tends to pile up in front of it, if you will, and create so much pressure that the object will actually explode before it hits the ground. So this is exactly what happened with this Tunguska event of 1908. It exploded. The estimate is up about 5 miles in the atmosphere, and the blast wave radiated out, and it flattened. Where it exploded was over old-growth taiga forest. So we're talking about forests of trees that are 2 and 3 feet in diameter. About 820 or 30 square miles of that old-growth taiga forest was completely flattened. And when you look at the aerial diagrams of it, what happened is that there was the epicenter of the blast. The shock wave came down and was so hot, about 200 miles directly below the epicenter got incinerated to almost nothing. Then as you go outside of that, the trees are broken off and splayed over in a radiating pattern from the epicenter. So by studying the pattern of tree destruction, the geologists were able to, and astronomers and other scientists who were looking at this, were able to calculate the intensity of the blast wave, how much pressure it was. The pressure wave from that blast actually encompassed the planet twice. And barographs, which are atmospheric pressure devices, had just been installed like a couple of years before in England. So they were able to, and unbeknownst to them, see, that's the thing, when this event happened, nobody really knew. But in England, they were monitoring these barographs, and they saw that a pressure wave passed over England, and nobody knew what it was. And then 11 hours later, a second one passed over England. They still didn't know what it was, but they made, notes and records of this. And it was only like 20 some years later, after Russian scientists got to the site of the Tunguska blast, that they were able to put 2 and 2 together and realize, well, that pressure wave passed over England something like an hour after the blast in Siberia. Maybe it was a couple of hours. So then they realized, and from that, they were then able to conclude or derive considerably more information about the nature of the blast. Now, that the intensity or energy released during that atmospheric blast has been estimated to be around the equivalent of a 15 megaton hydrogen bomb explosion.
Wow.
Now, a 15 megaton hydrogen bomb is about the size of the largest nuclear warheads in the American arsenal back in the 60s and 70s during the peak of the Cold War. Sure. And basically a 15 megaton bomb could wipe out any sizable metropolitan area on Earth. Because they were a bomb of that size was known as a city buster, because basically you drop it on any major city. I'm near Atlanta, but it could be Washington, D.C., it could be L.A., it could be Chicago. It doesn't matter. You've pretty much destroyed the whole city.
For sure, yeah.
And the object that came by the Earth last week was estimated to have been possibly up to 427 feet in diameter.
Yeah.
Well, because assuming that it's a very roughly circular object, volume scales as the cube of the radius. So what that means is that you look at an object to get its volume, like with Tunguska, you would go the radius, which say is 75 feet, that cubed, then that times basically 4/3. So the formula is 4/3 r to the third power. And then that gives you the volume. So if you take the volume of this object using that formula, it's about 18 times larger, actually, than the Tunguska. So you can think of it essentially as being in the ballpark of 18 times more powerful than the Tunguska blast, if that thing had struck the Earth.
Wow.
Now, a blast of that power, that's not only a city buster, that could pretty much like wipe out an entire state. What state are you in, Xavier? Where are you located?
I'm on the East Coast.
Okay, well, yeah. So,
I mean, it's gone. I mean, wherever I am, it's gone if something like that happens, for sure.
Yes. Think of the state of Virginia. Something the size of the state of Virginia, you would pretty much have total devastation. And it would be even worse if the object fragmented into multiple pieces. And again, one of the things that happens is that, when they dropped the bombs on Hiroshima and Nagasaki back in 1945, most people they imagine a bomb falling and then hits the ground and it explodes. Well, that's not how this was done. This thing was detonated. Those atomic bombs were detonated in the atmosphere, because what happens is if it hits the ground, then the ground absorbs a lot of the energy. They wanted to release as much energy into the atmosphere as possible, because that increases the radius of destruction. See, so an object that like say the size of the asteroid last week, if it comes by and it fragments as it's coming into the atmosphere, it would actually turn into more like a shotgun blast.
Right.
You see,
Right.
you could have half a dozen or 10 or 20 pieces of that coming in, and that would spread out as it's penetrating the atmosphere and really create a tremendous amount of surface destruction.
I mean, and when we look at, how many times this has happened in the history of civilization, I mean, how many times do you think that this has happened, this has occurred on Earth? I mean, it seems like, this happens over and over, but in your research, do you get to a point where you see humans build up to a certain point in technological advancement and then there's a cataclysm followed by a flood, or is there a pattern that we can look at?
Well, yeah, it seems, of course, one of the things that's coming from these studies is that, these kinds of cosmic encounters happen with much greater frequency than anybody was imagining even a few decades ago. And you see, here's the thing about, Xavier, to think about. With Tunguska, there was no crater. Cratering, like, I don't know if you know Meteor Crater, the famous crater in Arizona.
Heard of it.
That's okay. There's a crater in Arizona near Winslow, and it's about 1 kilometer wide and 600 feet deep. And it was caused by the impact into the ground of an iron asteroid. Now, it was estimated to be roughly in the ballpark of the same size as the Tunguska event. Here's the difference, though. Tunguska event is a much lower density object. It was almost certainly a piece of a comet. So therefore, its density is not going to be, density is based upon the density of water, which is 1 gram per cubic centimeter, right? If you go out and you pick up an average rock next to a creek or river, that's going to be around 3 grams per cubic centimeter. A piece of cast iron is going to be about double that, see? Now, when an object, let's picture an object 100, 150 feet in diameter. If it's low density like Tunguska, it will explode in the atmosphere. But if it's a higher density, if it's more like an iron asteroid, which would be, you can imagine this, the objects that the Earth might encounter run the gamut from, on one end, you might have an object that's no more dense than a snowball. On the other end, you might have an object that's the same density as a piece of cast iron. And then you've got everything in between. There's a whole continuum. And snowball, cast iron, those are kind of, in oversimplified terms, those are the endpoints of that continuum. So the object in Arizona was primarily iron, an iron-based meteorite. And this is known because you can find pieces of the meteorite that are distributed all around the impact crater. So that's the difference. If you have an iron object or a higher density object, it will tend to penetrate the atmosphere, strike the Earth, and leave an impact crater. Eventually, the impact crater will get obscured by erosion and sedimentary infill and things like that. And then it becomes what's called an astrobleem, which means star wound. And it's maybe not necessarily a big obvious hole in the ground. If you pull up pictures, Xavier, of Meteor Crater, Arizona, you'll see pictures, and it's a big, obvious bowl-shaped hole in the ground. Okay, if you're following this so far, here's the significance. The lower density objects like Tunguska are 5 to 10 times more prevalent than the higher density objects that leave observable impact scars in the Earth. So the significance of that is when we start crater counting, that will not necessarily give us an accurate assessment of how many times we're encountering things from space. Because the estimates are that the meteor crater in Arizona happened somewhere from 25 to 50,000 years ago. So let's say it happened, 30 or 40,000 years ago. The hole is still there, right? With Tunguska, what you had forest blow down. And within another century or two, there won't be really any obvious evidence that this tremendously destructive thing happened there, see? Now, when you consider that the Tunguska-type encounters might be as much as 10 times more frequent than a meteor crater-type encounter, now you begin to realize, well, yes, so we're realizing that these kinds of encounters could be way more abundant than anybody had imagined. And again, and one of the other things that has emerging from modern research about the structure of meteor showers and so on, and which are all generated from the disintegration of comets, is that there could perhaps be clustered impacts, periods of higher than normal encounters between Earth and this cosmic debris. And that's a very interesting idea. So there may be periods of clustered bombardment. In fact, going back to the KT boundary of 66 million years ago when the dinosaurs disappeared, it now appears that there was maybe a half a dozen impacts clustered around that boundary. And one of the reasons that some of the early critics said, well, there's evidence that the dinosaurs were already on the way out before the big impact. Well, that was probably true, but there were 3 or 4 smaller impacts leading up to the big one, and then there were several more after the big one. So what you had was a period of clustered bombardment, and by the time it was all over, the entire biosphere had been completely remodeled, and dinosaurs were no longer part of it.
Absolutely incredible. Wow. Just to hear you speak about all of this, I mean, it's amazing to me just to think at how frequent this is, and not as a matter of if, but more of a matter of when this is going to occur. I mean, it makes me wonder, what is the solution for something like this? I mean, let's say that, would an early warning system even be something that, I don't know, mainstream, the powers that be would release to us, because it would just create a panic around Earth, right? If there was an asteroid coming at us, most likely you're going to want to be subdued. You're not going to want to know about this. At least that's what they're going to think, right? So, is there any viable solution to this event that seems to be happening quite often?
Yes. Well, step number one, which has been advocated for a couple of decades now by, the astronomers and scientists that have been following this, is that we need to begin counting. We need a census of the things that are in space and that have the potential to become Earth crossers. Because you have to understand that you've got two types of trajectories out there that could potentially involve impacts with Earth. One is you've got a hyperbolic orbit. The geometry of the orbit's hyperbolic. A hyperbolic geometry is open-ended. So if an object comes in and it's determined to be on a hyperbolic orbit, what that means is it's going to come in, make a passage around the sun, and then it's going to head back out into space, and it's never coming back again. But then you've got elliptical orbits, and they're usually, you can almost think of like a ping pong game between the sun and Jupiter. You can have these long-term orbits that are hyperbolic. If they come close enough to planets, the gravitational effects of the planets, and especially Jupiter, because that's the big boy of the bunch, the geometry of their orbit can be altered, and what is an open-ended hyperbola can become a closed ellipse. Now, once it becomes a closed ellipse, it's going to stay in this cosmic ping pong game between Jupiter and the sun, back and forth.
Okay.
Now, that comet is going to then begin to undergo a process, because when a comet is in deep space, way out there, it is going to be essentially in deep freeze, right? There's going to be something that occurs probably on the stellar or galactic level that upsets the reservoirs of comets that exist out beyond the orbit of Neptune. And there are these hypothetical reservoirs. One is called the Kuiper disk, and the other one's called the Oort cloud. And they contain potentially billions of comets. Now, if you have an event that occurs on the galactic level, and this is all still theoretical, but something apparently will cause the dislodging of comets from this very delicate orbit that they're in, way out there, and it can send them this cascading event into the inner solar system. And it turns out that the planets, the outer planets, happen to be spaced just exactly what they would need to be in order to basically draw these comets in. Neptune, for example, if Neptune captures a comet, Neptune can then hand that comet off to Uranus. Uranus can hand that off to Jupiter. Then Jupiter, which is like the big boy of the system, will do one of two things. It will gravitationally accelerate that comet, which means it then heads back out into space, or it will decelerate the comet, which means it begins to drop in towards the sun. At that point, it can become an Earth crosser, meaning that its orbit can intersect the orbit of the Earth. Now, once that object comes into that orbit between Jupiter and Earth, it will become active, because comets are loaded with volatiles, for example. So once they begin to heat up, and once they come into the gravitational force fields of the inner planets and the sun, they will become active, and they will start outgassing, and then they will start actually disintegrating. And one comet nucleus can become multiple nuclei. We saw this actually happen back in 1994 when comet Shoemaker-Levy 9 made a very close pass by Jupiter, and a single comet nucleus was ripped into 21 separate pieces. And so what you now had was a single large comet nucleus gave birth to 21 smaller nuclei. Once the astronomers were able to track the geometric shape and the velocity of those pieces, they're able to now predict where it's going to be and when. And that's when they realized that 12 months later it was going to impact Jupiter. And sure enough, it did. In the summer of 1994, you had 21 impacts into the Jovian atmosphere. And so what we learned from that was a number of things, is that it's very typical for one comet nucleus. Once it comes into the inner solar system and becomes active, it can begin to undergo a hierarchy of disintegrations. So what that then means is that now its orbital path becomes littered with that debris of the disintegrating comet. Mm-hmm. And each year, when we have meteor streams, like we just experienced the Orionids, right? So when you have meteor streams, whether it's the Leonids or the Taurids or the Draconids or the Perseids, each of these meteor streams is associated with a disintegrating comet. Now, the idea is that when the comet initially begins to disintegrate, there will be areas within its orbital pathway, if you want, where this material, this byproduct of its disintegration, is going to be more densely clustered, and in other places where it might be much less frequent, more sparse, if you follow what I'm saying. So if those orbits intersect the Earth's orbit, then the critical issue is the Earth passing through that orbit when the density of material is relatively low, meaning the probabilities of an impact on Earth are relatively low, mm-hmm. or is the Earth passing through the stream at a point where the material in the stream is much more dense? Imagine this, Xavier. You're driving along, this is the analogy I use, you're driving along a country road and there's nobody else on the road except you. So you can kick back, you can listen to tunes, you can, look at your iPhone or whatever. But now you're coming up to an intersection, right? Now that intersection is a major highway. Now, when you're crossing that intersection, that's when you've got to be careful, because now suddenly the potential for a catastrophe is increasing. And the other factor is that, if it's a major roadway, like any roadways around any urban area in the U.S., that if you're out there driving at 5 or 6 p.m., there's going to be a whole lot more traffic than if you're driving at 5 a.m. or 4 a.m. or 3 a.m. in the morning, right? Mm-hmm. Well, the same analogy holds. It depends on, you're not only crossing the stream or crossing the highway, it's also how much traffic is there at the time you're crossing. Mm-hmm. So we cross the Taurid meteor stream twice each year, right? Most of the time we pass through it, and what we get is a fairly impressive meteor shower, meaning that the material that we're encountering is just small. It might be the size of a fingernail up to a few feet in diameter. If you got an object that's a few feet in diameter coming into the atmosphere, it creates a magnificent fireball. But so, excuse me. So the idea here is that the Tunguska object was June 30th, which is the peak of the summertime Taurids. It also came from the direction of the sun. Mm-hmm. Well, because the Taurid meteor stream, picture, it's going out not quite to Jupiter. It turns around and it comes back. And as it's coming down towards the sun, it's accelerating in its velocity. It sort of slingshots around the sun in what's called its perihelion passage. It comes back from around the sun and then begins to head back out towards Jupiter. So when we cross the stream in midsummer, around June 30th, if you're looking up the stream from the direction that these meteors are coming from, you're looking towards the sun. So they tend to be invisible. And what happened was on early morning of June 30th, people didn't see this thing till the last minute. It was already in the atmosphere, coming through the atmosphere when people began to see it. Now, the other peak, when we're crossing the stream the second time, is centered right around Halloween. In fact, the Taurids have been sometimes referred to as the Halloween meteors. Now, at this point, we're crossing the stream, but the stream is coming from the direction of Jupiter. So you're looking out into space away from the sun. Mm-hmm. So now you can actually see the meteor stream. You can see the meteors coming in. But again, the whole point I'm trying to make, is that the Taurid meteor stream probably originated from a giant comet that came into the solar system between 25 and 30,000 years ago, began to undergo this hierarchy of disintegrations, littered near Earth space with the byproducts of its disintegration, and Earth has from time to time encountered this stuff. And the last time it happened on a major scale was 1908. Although right after seismometers were placed on the moon during the Apollo program, they were still operating, I think it was 1976. On June 29th or 30th, there was a clustered bombardment on the moon that was almost certainly Taurid meteor stream in origin. And there's been a number of other interesting encounters that were likely Taurid meteor stream related. So that's a little bit how it works. It's a complex system, and it's not, a lot of the critics early on were imagining that, well, if you had a mass extinction event that was caused by an impact, that should have just been one event, clean, it's done, it's over with, right? Because what they're imagining is a single impact and they're also doing crater counting. So right there, if you're only relying on crater counting, you're not going to get an accurate determination of how many times Earth encounters cosmic debris.
Yeah.
Right. So what they were doing was they were crater counting and saying, well, based on this, we know that, major impacts that we need to worry about only happen, say, every million years. Right. Well, this is really what it's done is created a false sense of security, because that's not the case at all. And the big impacts, like the dinosaur impact, yes, these things are very infrequent. But, a dinosaur scale impact is basically going to wipe out civilization completely, probably cause the extinction of the human species. Because if you look at what's now known about that KT impact, I mean, it was pretty wild stuff. I mean, you had global firestorms, you had you had acid rain with a pH of 1 that, on large parts of the planet. Now, pH of 1, that's battery acid. Try to imagine a global rainstorm of battery acid. How did anything survive? Seismologists have looked at it and said, well, with an impact of that intensity, you probably had failure of every fault line on Earth. You also had gigantic volcanism going on. The Deccan Traps of India seem to coincide with the impact. They may have actually been triggered by the force of the impact. That, in turn, then began to eject billions of tons of sulfuric aerosols into the atmosphere, which then would have added to the chaos of that time. So, but the thing is, my point is, an event like that is not really the thing that we need to be concerned about, in my opinion. What we need to be concerned about is the smaller stuff that could perhaps take out the east coast of the United States, not cause a mass extinction of the human species, but could cause economic destruction that would take literally decades to recover from.
Yeah, I mean, the system as it is seems to be built on toothpicks. I mean, you move one toothpick around even a little bit, and suddenly you find, this havoc of, I mean, just for an example, I was traveling a couple weekends ago, and was driving up on the highway, and there was an accident reported a little bit north, and there was traffic backed up for miles, miles, and miles and miles. So, I mean, if there's an event that maybe isn't as big as something that caused the dinosaurs to be extinct, but small enough that it could take out something like a major city, then I mean, it's definitely something that we need to be aware of and conscious of. I mean, it seems like that mainstream media has sort of prepared us in a way for these types of events. I mean, there's a lot of apocalyptic type thematic movies that are coming out in the mainstream. Do you think that there's any correlation or connection? Do you think that humans just have some sort of fascination with this type of thing, this type of theme, or is it something more?
Well, I think that, we carry this imprint. Our ancestors suffered through huge catastrophes. You know, the not the Cretaceous Tertiary, but the Younger Dryas catastrophe of 12,800 to 13,000 years ago was a major global event. And it did cause a mass extinction of about half of the great megafaunal species of Earth. It caused the sudden extinction of the Clovis culture that was very prevalent in North America. So we do have in our immediate past a global event that was not as severe as the Cretaceous Tertiary boundary, but in its own way was probably, when you go back and you begin to look at the evidence for catastrophic events in Earth history, it's pretty safe to say that the Younger Dryas boundary catastrophe may have been the most severe event in somewhere between 3 and 5 million years. And so really our modern history emerges out of that event. You know, the human population, I think the evidence is now pretty overwhelming that the human population took a major hit. You know, when you start thinking about the amazing megafauna that was living throughout the ice ages, you know, the mastodons and the 4 species of mammoths and the giant ground sloths and the cave bears and the huge camels. And I mean, you got a list of about 120 of these amazing mega mammals that roamed the earth. And right around the time of the Younger Dryas boundary, they went extinct. And, you know, there have been various theories as to what caused this extinction. And the dominant one, really since the 50s and 60s, has been that human hunting was to blame, human predation. But for many, many reasons, and we could do a whole conversation just on this, for many reasons, that idea is now untenable because the extinction happened too fast. The estimates for the number of people on the Earth during the latter stages of the Ice Age, let's say 14 to 15 to 16,000 years ago, was less than the number of woolly mammoths. So, you know, then from that, you're going to surmise that Paleo-Indian hunters on foot using spears were able to exterminate somewhere around 10 million woolly mammoths worldwide so quick that they weren't able to reproduce the species. You know, the idea just really becomes almost laughable when you think about it. But that was the dominant idea. And, you know, that idea has now been challenged. It's been challenged all the way along, but it seemed to fit the narrative because the idea now is man is destroying nature on Earth, and anything that can now be invoked to support the contention that humans are bad for the planet is given a lot of press. And so, you know, this is not to say that we you know, don't have a bad imprint in a lot of ways. We do. But in some ways, you know, we may actually end up being the salvation for the planet because the human species are the one species out of all of the species on Earth now that can anticipate the next impact. And what we realize now is that impacts, like you even said earlier, much more frequent than anybody had even imagined. And, you know, there are 5 great mass extinctions in Earth history, the terminal Ordovician, the late Devonian, the Jurassic Triassic, the Cretaceous Tertiary. All of these extinction events are associated with either gigantic volcanism or impacts. And so, and there may be a connection between these large-scale volcanic events and impacts. There may be a connection between collapses and reversals of the geomagnetic field and cosmic impacts. And there certainly is a direct connection between extinction of species and cosmic impacts. Where, to me, this thing now gets really interesting is now when we start talking about the extinction of human civilizations in the past, because we may be looking at the same mechanism. There will be times when nature just convulses. And I think that the most evidence is now pointing for a cosmic trigger behind these convulsions of terrestrial nature that have led to mass extinctions and complete reorganizations of the biosphere. I mean, you think about this, Xavier. You know, up until about 13,000 years ago, over half of North America had a climate like the South Pole. And you had these massive ice sheets. You had the Laurentide ice sheet that was sent out over Hudson Bay. It may have been as much as 2 miles thick. Then you had the Cordilleran ice sheet that covered all of the Canadian Rockies and up into Alaska. And between those two, you had somewhere between 6 and 7 million square miles of the Earth's surface buried under ice, right? When all of that ice accumulated, what that meant was that ocean levels had to go down correspondingly. In other words, you've now taken 6 or 7 million cubic miles of water out of the ocean basins, frozen it as glacial ice, and accumulated on the continents, right? Mm-hmm. So now when ocean levels go down 400 feet, you're exposing most of the continental shelves that rim every continent on Earth, right? So now during the Ice Age, you've got this whole ecosystem that emerges on these continental shelves, right? And if you had humans during that time, the most benign place to live, the most favorable real estate would have been coastlines of the Earth, because the oceans would have helped to moderate the severe cold of the Ice Age. And so if you had human cultures evolving during the Ice Age, just like when you look at the origin of modern human culture into this global culture that we've got now, it starts with port cities, and then those port cities become places of trade, and they become part of a network of economic exchange. And just as we see civilization forming on coastlines in the last 300 to 500 years, it would have been natural for villages and communities of people, even if there were cities, for them to form on the coastlines. Well, those coastlines now, Xavier, are 400 feet under ocean water. Mm-hmm. So, that's part of the reason why I say it's premature to close the book and say, well, we know that 13, 14, 15,000 years ago, the only thing people were doing was leading a hunter-gatherer existence. Right. And they never got beyond that until the Industrial Revolution or whatever. See, because once you begin to understand how extremely this planet has been remodeled over and over again, you realize, well, whatever existed here before, we shouldn't be surprised that we're not finding much evidence of something,
Yeah.
So the thing we got to do is, I think, is first of all, is to begin to counting these, try to locate. I mean, the estimates are now that we maybe know 10% of the potential Earth impactors out there. So the key to surviving an event like that is how much lead time do we have? What we learned from this event last week was 0 lead time.
Right.
Now, if that thing had come into the atmosphere, we'd be picking up the pieces for years to come. And we would have, and if it had happened over a populated area, there could have potentially been millions of casualties. The economic consequences of that would have, like I said, would have been felt for years. And see, that thing, Xavier, is just a small object. If an object 1,000 feet in diameter, now you're looking at something, 100 times Tunguska. Wow. And an object of that size could take out the entire East Coast. If it hit the oceans, it would generate huge tsunamis that, making landfall, might have been 200 to 300 feet high. There'd been an order of magnitude beyond the big tsunamis that we saw hit Japan and Indonesia in the last couple of decades. So the consequences of it would be severe. It wouldn't cause a mass extinction like the KT, but it would cause economic repercussions and huge mortality events. Locally, it could cause mass extinctions. So what we need to be doing is we need a census of these things, and this is why I'm a firm believer that we need to move forward with a vigorous space program. Because Absolutely. Right now, basically, we're sitting ducks. And if we have a vigorous space program, we're in a position to react to it, to respond to it. And really, if we detect an Earth impactor early enough, really all you got to do is nudge the darn thing, and then a direct impact can become a wide miss just with a nudge, see? So, there's any number of proposals on the drawing boards for asteroid impact mitigation
Randall,
a comet would be, yeah, go ahead.
Let me bump in for a second here. I'm curious about all of this, because if you're anything like me, there's your senses are kind of in tune to this vibration or frequency or whatever is going on here. I'm not exactly sure how to define it, but it feels like my antenna is up for these events when they're happening, when they're coming, worldwide events. You could see the work of Dr. Roger Nelson, the Global Consciousness Project. It seems like humans are linked into a global network of consciousness where they're communicating in some way about what's going to happen. So, today I was reading something that was trending on Twitter today, that the Greenland ice sheet braces for record single-day meltdown after a Europe heat wave moves north. I mean, there seems to be such drastic climate change that we're encountering this freak weather. I mean, it's record-breaking weather. I mean, you've written on the effects of CO2, and you've talked about how carbon there's a demonization of that. What do you think is happening when we're looking at these extreme weather phenomena?
Well, I'm kind of glad you brought that up because, I've been studying weather and extreme weather for years and years. It's part of the thing that I look at. And I've cataloged these extraordinary events that have occurred over and over and over again on any time scale you can look at. And, again, this would be something that would be probably the subject of a whole discussion in itself. But compared to some of the things that we've looked at in the recent past, I personally don't think we see anything that's that unprecedented now. If you want to talk about droughts, yeah, we've had droughts that are way, way more severe than anything we've seen in the last 50 years. If you want to talk about floods, yeah, we've had these enormous floods that have, wiped out entire watersheds. We've, forest fires. One of the things that I've studied and written considerably about is some of the great forest fires of the 19th century. And these forest fires were just phenomenal. They were just on a scale that makes them almost unbelievable. There was the Peshtigo fire of 1871. One of the interesting coincidences, bizarre coincidences, if you will, probably everybody's heard of the Great Chicago Fire, right? Mrs. O'Leary's cow kicking over the lantern. You ever heard of that?
Sure, yeah.
Sure, the Great Chicago Fire. Well, as I have done, I've gone through the literature and read over and over the eyewitness accounts and the write-ups about the Chicago Fire, and it basically started at 9 o'clock on Sunday evening, October 8th, 1871. And Chicago Fire to this day is still the most devastating urban fire in American history. The most devastating forest fire in terms of sheer mortality was the Peshtigo, Wisconsin fire. And here's what's interesting. You read the accounts about that, the eyewitness accounts and so forth, they're able to pinpoint the inception of that fire, and guess what? 9 o'clock p.m. Sunday, October 8th, 1871. In other words, the most devastating urban fire and the most devastating forest fire in American history started simultaneously, right? In both cases, what you see is that in terms of Peshtigo, people described how the fire came out of the sky and it lit the treetops on fire first. Just like in Chicago, they're describing how the fire is coming out of the sky and sets the tops of buildings and church steeples and things like that on fire first. Now, the Peshtigo fire basically was like a cyclone of fire that wiped out thousands of square miles within a day. Then there was the Hinckley fire of 1883. Same thing. It was a cyclonic firestorm that consumed a swath of forest that was about 20 to 30 miles wide and 50 miles long. And it did this literally in a matter of a few hours. And the flame column was so high that it could be seen from Duluth, which is a city up on the shore of Lake Superior. Well, the distance between Hinckley, Minnesota and Duluth is far enough that if you were able to see the flame column, it means that the flame column had to be at least 5 miles high. So I could go through this whole litany of hurricanes, of tornado spells, forest fires, floods, and by the droughts. And by the end of this, you'd go, oh my God, this stuff is what we're experiencing in the last decade or two really isn't worse than that. And as far as the global warming, when you look at carbon dioxide is very, very critically important as a greenhouse gas in the first 50 to 100 parts per million. But its thermal capturability drops off very rapidly after about 100 parts per million. So that the curve that it actually describes in terms of thermal capture is a logarithmic curve. So that means it's diminishing almost like in a reverse exponential curve. So each incremental increase in carbon dioxide is doing less and less in terms of capturing long-wave solar radiation emanating from the Earth. And the way that computer models are structured in order to ramp up the effects of carbon dioxide is to introduce positive feedback amplification primarily through water vapor. And so the idea is that you're going to get this runaway positive feedback amplification because even though the carbon dioxide is acknowledged to not really have much additional thermal capture, it has enough that it increases the water vapor. And water vapor, of course, is the primary greenhouse gas. That it far and away overdominates carbon dioxide. But then that uptick in water vapor now then causes this feedback that causes more emission of carbon dioxide, presumably from the soil, from the oceans, from peat bogs, and so on. Then that causes more water vapor to go into the atmosphere, which causes more outgassing of carbon dioxide. But the point is that without those positive feedback amplifications, the thermal capturability of carbon dioxide is, by the time it hits 400 parts per million, is pretty much exhausted, because it only deals. It's only interested, carbon dioxide is only interested in that wavelength of, say, about 14 to 16 micrometers or microns, right? Mm-hmm. And that little window is pretty much already saturated. So it's just like if you had a sponge and you put it on the table and it's a dry sponge and you start pouring water on it, that sponge is going to suck up the water. It's going to keep doing it until it gets saturated. The point it gets saturated, you add more water, but the water is now going to just run out of the sponge. It's going to leak, right? So in a sense, that's what's happening. Once that 14 to 16 micron window, wavelength micron window gets saturated, now it's just leaking out into space. So I think from my own studies, I think the sun is a much bigger factor. Mm-hmm. And we could do a whole discussion about the sun and what we now know about the sun. And it's a much more dynamic. You see, for most of the 20th century, the assumption was of the solar constant, and the idea that the radiant output of the sun didn't vary enough to even bother with. And so when the IPCC was launched in the early 90s, all the computer modelers ignored the role of the sun because they were still believing this model of the so-called solar constant. And therefore, because the sun is invariable, we do not need to even bother with it in our models. But as it turns out, tons of research since then have shown that, oh no, the sun is actually considerably more dynamic and variable than was being assumed 30 or 40 years ago.
So I'm so sorry, yeah. Randall. Let me just bump you really quick. We've got our first super chat. Thank you so much for $2. Never so clever as this. If you'd like a question for Randall, please do send us super chats to help us keep this going here. But he, never so clever as this, asks for you, Randall, are preventative forest fires a realistic task?
Burning off the underbrush, yes, I would say it is. And I think the Native Americans understood that. And that's why they deliberately set forest fires. Because what has happened is because of our environmental policies over the last 30 or 40 years, it's allowed the accumulation of a huge fuel load on the forest floors. And these fuel catastrophic fires. And California has had one of the most draconian hands-off policies. There's going to be natural mortality of forests that have nothing to do with human activity. So at some point, trees do die. And, back 50 years ago, you had the Forest Service stratagem was to create fire breaks. They had roads that they would maintain that firefighting equipment could get into. Well, a lot of those roads have been closed down. I mean, I travel through the western states all the time, and I can testify that roads that were accessible even in the 90s are now gated. You can't get in, and the roads are basically growing back. There's now trees and stuff. Even if they opened the gates, you couldn't drive on them now because you've got saplings and things that are 10 and 20 and 30 feet high growing where it used to be roads. Well, when you have a forest fire, you want to get the forest fire fighting equipment in there, but you see that's been compromised by the hands-off policy. And, Native Americans didn't have a hands-off policy. They regularly, this is well known now, they regularly set forest fires because what they would do is they would be non-catastrophic. They would basically burn off the dead debris and the fuel load that was accumulating on the forest floor, and the large trees would come through unscathed. But now we've got these crown fires because there's so much fuel load. I mean, there are millions and millions of dead trees in California forests right now. And they've finally begun to change their policy a little bit and say, well, yeah, we can go and we can begin to harvest some of that dead timber. Mm-hmm. Well, they're forced to because that dead timber is what leads to these catastrophic fires. Mm-hmm. But even the catastrophic fires in California last year before, mm-hmm. When you look at some of the fires we were talking about, the Peshtigo fire, the Hinckley fire, or the big burn of 1910 in Idaho, or the New Brunswick fires that happened in the early part of the 19th century, these are firestorms that are in a category all by themselves, and they are so extreme that they're almost impossible to comprehend. I mean, think about that. If you had the 5-mile flame column for the Hinckley fire of 1883, what does that mean? I mean, you're talking about trees that are 100 and 150 feet high, mm-hmm. right? How the hell do you get a 5-mile flame column out of that? So there's something else going on there that we haven't figured out yet. And I've got some theories on that, and I've written on it, and there's a couple of videos up online where I am talking about that in more detail, these catastrophic fires. But I guess the point is, when you immerse yourself in the study of global change, you realize that, yeah, there have been freakish things going on all along. And you can't go, think about this, Xavier, the big witch pogroms of the 1600s, 15 and 1600s. Most of those tens of thousands of wise women that were in a lot of cases burned at the stake or hung or kicked out of the in most cases they were killed, but they were basically, if you look what you see happening every time you've got one of these increases in the frequency of witch pogroms, it's after freakish weather, because they're getting blamed for, there'll be some extraordinarily cold summer, so the crops die in the field and people get hungry, so they're looking for a scapegoat. So what they now do is they burn 1,000 witches at the stake, and that in their minds they now believe that they've addressed the problem. I kind of look at carbon dioxide as being like our modern witch. We want to blame everything on carbon dioxide when, in fact, I think that the big factor affecting the warming of the last century is the sun. Because you got to keep in mind, Xavier, that we came out of 300 to 400 years of a period called the Little Ice Age. Now, the Little Ice Age is considered to have been one of the coldest episodes of the entire Holocene. The Holocene is 11,600 years old. We're in the Holocene now. It's the geological epoch that followed in the wake of the Great Ice Age, right? So when the ice sheets melted, 11 to 13,000 years ago, melted away, it completely changed the biosphere of the planet. Like, we were talking about sea levels coming up drowning those continental shelves, millions of square miles of continental shelf that were exposed during the late glacial maximum with a 400-foot lowered sea level. All those ecosystems, they were drowned. So all of that was lost, right? So think about the change that would be involved if we were to somehow able to turn Antarctica, the South Pole, into a climate like North America. How would we do it? How would nature do it? Nobody has any idea, but that's what happened. I mean, you don't have an ice sheet that's, a mile to 2 miles thick, covering 7 million square miles of land without having a polar climate. And yet within a few thousand years, the ice sheets were gone. The polar climate had shifted to the modern temperate climate of Canada and the northern United States today. How do you explain that? Nobody has an explanation for that at this point. But it was orders of magnitude greater in severity than anything we've experienced in our lifetimes. So it's all a matter of perspective, I guess, is what I'm getting to.
Mm-hmm. Mm-hmm. Yeah. I mean, it seems like there's many of these events that you are finding through your research, and they're happening all over the world. There are these impacts, and some that don't leave these impacts at all. And so, I think and the awareness of this topic is the first step. But
yes,
also in mainstream science, there seems to be this very widely held opposition to these ideas. It's as if they just don't want to accept reality. I mean, I don't know what it is, but it seems like you've been, held back from pursuing this. I mean, many of the people that we've had on the show that address what some would call counterculture issues have, been threatened with their tenure. I mean, there's many ways that they have been threatened from pursuing their research further, just so that we can understand better who we are as a human species. Why do you think there's so much pushback in the mainstream?
Well, I think there's a lot of politics are involved.
Money?
Money is a big part of it. Money, power, politics. Yeah. I mean, the whole, I think of it as the global warming juggernaut. I mean, right from the outset, you got to understand that the mandate of the IPCC was to make the case that humans are mainly responsible for climate change. So in that case, with that mindset right from the outset, where we're not going to look at the sun, we're not going to look at changes in the geomagnetic field that could be a big factor. We're not going to look at the amount of dust in the atmosphere that is a consequence of volcanism, or even the result of encounters with, getting back to the meteor stream model, the end result of this process of disintegration basically is cosmic dust. And, Fred Hoyle and Chandra Wickramasinghe did a lot of work on this back in the 70s and 80s, showing what would happen in terms of global cooling with the accretion of cosmic dust. And nobody's ever really refuted it. It's basically just been ignored. And what was happening, I think, is that, we started sending up solar satellites and observing the sun like within the last quarter century, last 20 to 30 years, right? Until we had those satellites in place and really started making detailed studies of the sun, nobody could say for sure that the sun was a major player in global climate change. Well, now, in tandem with the scenarios emerging about global warming, we're learning about the sun and that it's a much bigger player in global change than anybody had imagined, but it's still being basically ignored to this day. And so everything that's basically happening now, the attempt is to lay it at the feet of human activity. And, we hear about the Green New Deal and that we're going to have, catastrophe, in less than 12 years. Somebody came out recently saying, well, we only have 18 months. Well, I'm old enough to remember that we've had these predictions now going on for 30 years, and they've never happened yet. And I think that the reason they haven't happened is because the science is flawed, and you can't get an accurate assessment of climate change or global change or environmental change if you're ignoring the natural factors that we know have been operational on any time scale we can look at since the world began. And they're not going to stop. They're not going to stop influencing the climate. They're not going to stop influencing the environment. They're going to keep right on. And here's my point, is there's going to be global warming and global cooling. You could take every human on Earth and we could go extinct, and the climate is still going to change. Sometimes there's going to be global warming where it's warmer than now, and other times it's going to be global cooling. And since the turn of the 19th century, the estimate is that we've global average temperatures raised by about 1 degree, right? About 1 degree. And it has, because we were in, like I was saying before, the Little Ice Age was probably almost certainly the coldest 3 or 4 centuries of the entire 10, 12,000 years of the Holocene, right? During the Little Ice Age, glaciers worldwide grew to their greatest extent that they had been in 10,000 years. So the end of the Little Ice Age coincides exactly with the beginning of us monitoring global temperature. So it's almost like saying, okay, well, we started monitoring the global temperature in February, and now in June, it's warmer, way warmer than it was 3 months ago. Well, you have to look again at the context. See, well, of course it's going to be warmer on average if it's going to be May or June than it is in February or March. But that's natural. See, we're looking at such a small slice of time that it's not really accurate for us to extrapolate from looking at 100 years of climate data to know what's going on. So we have to resort to paleoclimatological data, the proxies that nature has provided for us to understand global change in the past. And when we do that, and we have a context for understanding what's going on, now we realize that, oh, okay, so it's not as extreme or freakish as I thought it was. We're talking, California's had droughts that have lasted for 20 years, 30 years, and this was long before the Industrial Revolution. And in every one of those, we could address in the same way. So I think that, big mistake to ignore the sun, big mistake to ignore the natural factors that we now know cause climate change. And this is not to say that humans are not a factor, because we are. And we certainly do need to get our act in order. But I'm more concerned with particulate pollution, which is not carbon dioxide. I'm more concerned with plastics in the ocean, things that you can actually see and that we could address and do something about if the resources and the incentive was there. And I'm all for protecting endangered species, which mostly is due to habitat loss rather than climate change. So we need to figure out ways to create safe havens for species. And realize that, habitat loss is the biggest contributing factor to the extinction of species. So if we can begin to set aside reserves, places where species can thrive, but we also have to bear in mind that it's natural for species to go extinct. They do that. No matter what we do, some species are going to go extinct. And most of the extinctions of the last 100 to 200 years that could be have been island extinctions, because island ecologies they don't have the diversity that helps one, the diversified system that contributes to survival. And most of the extinctions that have taken place on islands was the result of invasive species, and it was really nothing to do with climate change. It had more to do with species that came in that displaced existing species. And those island extinction events, they're pretty much historical now. I mean, they're done with. So we're not going to really run into that anymore. So the main concern would be habitat loss, and far more of a factor than a half a degree or a 1 degree warming in average global temperature. But even there, see, what I'm getting at is that there are studies, and I have dozens and dozens of these studies in my collection, looking that the sun may have contributed conservatively half of the warming of the last 100 years. Then, on the other hand, you've also got the urban heat island effect. And this was another factor that's been ignored in the computer models, the fact that, when we started most temperature data collection stations in the late 1800s, early 1900s, were rural based. Most of them were at airports, and those airports generally were rural. Well, in the ensuing development of 100, 120 years, those, of course, we didn't have airports till the 1920s and 30s, but even before that, they were still mostly rural. And so the cities have grown, the amount of asphalt and concrete and heat trapping materials has grown exponentially. And there has not been adequate accounting for the amount of warming that would occur in the record based upon the urban heat island effect. And in fact, some studies have suggested it could be a third to half of the 1 degree increase in average global temperature of the last 100 years could be blamed on the urban heat island effect. Because yourself, you can start looking at like weather reports, and depending on a lot of factors, quite often you will see that the major urban areas are 2, 3, 4 degrees warmer than the surrounding rural areas. And that's because the concrete, the machinery, the asphalt, all of that is absorbing heat. And then that heat is re-radiated at night, and that'll cause it'll contaminate the purity of the temperature data that you're looking at. See, so they're attempting to correct for that right now. But what it seems to be showing up is that maybe 1/3 to 1/2 of the warming increase of the last 100 years might be, it's real, but it's urban heat island rather than carbon dioxide. So as soon as you get away from the urban areas and the masses of concrete, in my building business, one of the things we do is we design structures to take advantage of the thermal capacity of various materials such as concrete and stone. When we design a building or a house, we want to get solar gain during the day when the sun is accessible, and then at night when the sun is not there, the thermal energy that has been absorbed into the stone or the concrete or whatever, the thermal mass is now re-radiated into the space. So it's the same concept.
Wow, Randall, what an amazing interview. You are loaded with research, and it's clear that, people such as yourself are trailblazing this path for others. And you've got quite the following. Many of your fans in the chat tonight talking about your work, very enthusiastic about what you're doing, and they love, absorbing all this information. You've clearly done the research and the work, and, hopefully, and it seems like there's a lot of work for us as humans to do to better understand the cycles of our planet. And, maybe if we were lucky enough to have the support of the mainstream and science, maybe that process would speed up. But, maybe we just need a close call for that to happen, a closer call,
Yeah, I've said the same thing for at least a decade now, a close call, or even, I hate to say it, a strike, a repeat of 1908, I think would be a big wake-up call. Because I really do think that, we're spending so much time now, especially, with confrontational geopolitics, warfare, preparation for war and all the saber rattling that's going on. I look at all of that as being just basically contrived differences. And we're really all on the same planet. Yep. We're all in the same boat. And really the big issues affect all of us. And I think we're wasting a lot of time and effort and attention on these made up conflicts, when really, what I'd like to see is an international program to, offload our industrial civilization from the planet, which we could essentially do. The engineers have had plans on the drawing board since the 1970s. Once you get outside the atmosphere, solar energy becomes really a viable way of powering systems, of powering factories. And we could see it happening. A lot of it's really an encouraging thing to me that a lot of the private billionaires, from Elon Musk to Richard Branson and Amazon, Jeff Bezos, they're all very interested now in the private exploration and economic development of the resources of space. And I'm all for that, because I tend to think that human beings, our ultimate vindication is that we will become guardians of this planet. And we have had 10,000 years now where we've been between major global catastrophes, right? But when we look back at the record of the last 250,000 to 500,000 years, what we see is over and over again, there have been these enormous extreme spasms within the natural order, any one of which could cause major havoc with species, habitat loss, could pull the plug on modern civilization, could literally lead to 1 billion or more deaths. And basically what we're seeing within the context of the bigger picture is that we've had the longest period of generally stable climate that we can see in the last 250,000 years. And it's given us the opportunity to evolve as a culture and a civilization, a technologically based civilization, as we have. And so now we're in a position where we have the technologies to understand the Cretaceous Tertiary event, to understand the Younger Dryas events, to understand the Tunguska event and reconstruct it. 100 years ago, we didn't, see?
Right.
Now we have the technology to understand, the sun is a variable star.
Sure.
And sometimes it gets hyperactive. And when it does, the consequences to our civilization could be profound, see? So it's like we need to be taking all of this into account and realizing that, if there's even a small impact, it could be ecologically devastating to the biosphere. And we have the ability to prevent that. Now, does that put a moral mandate on us? I kind of think it does. And this is why I would oppose any effort to scale back our industrial civilization. I think we need to move forward. And by moving forward, if we look, since, I'm old enough now to remember when, living up in the Midwest, well, you can't swim in Lake Michigan because it's too polluted, or Lake Huron especially. Well, it's not now. The fish are back. We evolved culturally to where we could now, because we weren't preoccupied on the day-to-day business of survival, we were able to now turn our attention to the larger environment and say, it's not good that Lake Huron is poisoned. It's not good that we're dumping this crap into the rivers. Let's fix that. And we have been fixing it. And we need to continue fixing it. But going back to the Stone Age is not going to be, or going back to a feudal system is not going to be the answer, because basically at that point now we are vulnerable, our civilization is vulnerable, and the planet is vulnerable. And like you said, the next impact is inevitable. It's just a matter of when and the magnitude of it.
Yeah, Randall, I mean, you said it here, man. It really does seem that, technology, if people just spent less time, on their phones looking down at them, and maybe started looking around at what was going on around them as well, that maybe we would, but there is something to be said for, conversations like this and the ability to communicate with someone across the world. It's allowing us to generate information, collections of information that we would have never been able to collect before at the rate at which we're doing it. It's virtually light speed. So, there's a lot happening. There's a lot changing. And it's time that we grow up as a species. It's time that we start looking at this as a responsibility that we have.
Well said.
For the sake of our children's children, that we hand them a world that is habitable. And I wonder about that sometimes. But Randall, this has been such a amazing interview. We've gone over a bunch of different things. Is there anything that I could have asked you that you want to talk about that I haven't mentioned or brought up yet?
Oh, Xavier, there's lots of things.
Okay.
Maybe one would be the legacy of traditions that we've inherited from the past, from the people, our ancestors that have lived and died and experienced things that we're talking about. There's a whole legacy of traditions, mythology and legends and folklore, symbolic systems that have been preserved in various venues. through oral traditions, through architecture, through sacred writings. That to me is kind of like the other dimension of this, is that we turn from, the modern technological perspective, and we see that we have this traditional perspective that can so powerfully complement and enhance the scientific worldview. And that would be, again, a subject for a whole nother conversation. We could get into talking about the various myths, the stories of the great deluge, the stories of the alternating destruction of the world by fire and water, the stories about, some advanced civilization, whether it's Hyperborea or Atlantis or any of the number of names that have been given to it. The Garden of Eden. Mm-hmm. There are many of these themes that have come down to us. This is not to say, I'm not saying, if we go back, they were, driving cars and flying airplanes and doing all of this kind of stuff, because we could be talking about technological advancements here that wouldn't look anything at all like our modern industrially based civilization. Mm-hmm. And so I've done a considerable amount of research into what that kind of a civilization could possibly look like. And of course, in the aftermath of a global catastrophe or cataclysmic event, it would be very difficult to find the hard evidence. You could have an advanced civilization that is not producing plastics, right? That's not building automobiles. Although, if you take an automobile, put it out in a field and sits there, 200 years from now, you wouldn't find anything of that automobile. Mm-hmm. It's going to have rusted away. So, you could take, in fact, there's not much within 10,000 years. If we just walked away from our modern civilization and just left it to the vicissitudes of nature, what would we see in 10,000 years to tell us that we had existed and had built this amazing civilization with our great cities and airports and, highway systems? What would remain? Nothing you could see except a few isolated examples, such as the Great Pyramids of Egypt, probably Mount Rushmore, as long as there was no seismic shaking of that area that caused a collapse of the rock faces, you would still have Mount Rushmore there. But see, and that's without even a catastrophe intervening. You start throwing catastrophes into the mix, like I've been studying, and you realize how much geomorphic remodeling takes place during some of these. I mean, there are whole landscapes that are buried under thousands of miles of sediment. There are and that sediment was other landscapes that got stripped away and eroded by these intensely erosive events. See, people don't understand it. We're talking about, for example, floods from 12 or 13,000, 14,000 years ago that are measured in hundreds of millions of cubic feet per second. Even some of those smaller floods are on a scale where you couldn't reproduce them today, because they would require every single river, creek, and stream on Earth all flowing together times 10 or 20. So, this is the scale. We're talking about, floods that would wash away any urban area that existed on Earth were they struck by such a flood. You can't even imagine a flow of water that's 1,000 or 1,500 feet or even 2,000 feet deep, moving at 50 or 60 or 70 miles an hour. In the aftermath of a flood like that, nothing is going to remain. Mm-hmm. And what I'm describing is not science fiction. It's real. It's well documented. And this is something, on the Geocosmic Rex website, we've got a lot of videos and graphics. Cameron on the Sacred Geometry website has quite a bit of that stuff to show that, these outsized events have been a part of Earth history, and we need to understand why, and we need to address that with the question of, could such a thing happen again? Now, as far as those particular floods, it's not likely that would happen again, because those floods were generated by the rapid catastrophic melting of the great ice sheets. But how you would have gigantic floods like that is a small asteroid falling into one of the world's oceans, producing a tsunami that makes landfall and is 200 or 300 feet high or higher.
Mm-hmm. Wow, Randall, thank you so much. Why don't you give us, where people can find your work, the website? Are you doing any conferences? Where can people find your work and any conferences that you might?
Yeah, there's a couple of things coming up, and I don't have this dates or time, but this fall I've got several things that I'm going to be doing. One in Minnesota and one in Arkansas at Little Rock. I may be doing some more tours. I did a tour. I led a tour. I took about 75 people out into the field for over 10 days in Colorado in May. And we mostly were exploring geological features and archaeological features. So we were looking at the lost Chacoan culture of northern New Mexico and southern Colorado. I might be doing a field trip this fall. We'll just have to see how the time works out. What happens is, I've been doing a lot of writing, and I've been working for 3 or 4 years now on a book, and it's just trying to get this book finished. But I keep doing too many things. I keep going places and, doing podcasts and things instead of finishing my book. So,
Well, okay, so guys, we're gonna get out of here. We went super late. We were late to arrive, so we let it go a little bit longer so you guys could hear it. That's gonna do it for us. Thank you so much for listening. If you're listening to this on the YouTube version, please click the subscribe button. Make sure you click the bell so you get notified when we go live. If you're listening to this on the podcast version, get over to YouTube and search for the Human Experience Podcast. You can find out when we go live there if you're interested in finding our live shows. One other thing you can do if you're listening to us in the podcast version is you can just spread the word of the show. One of the most common things that I'm hearing, common themes that I'm hearing from people is that we've interviewed these amazing guests, amazing authors, amazing researchers, but people haven't found our work yet. So if you can get on iTunes and leave us a review, that would help us a lot. It's probably the biggest compliment that you can give us is a review on iTunes. So thank you so much for listening. My guest, Randall Carlson, tonight. What a pleasure. And we're going to get out of here. We'll see you guys next week. 2 seconds, Randall.